Hello, and in this video we're going to do a couple more examples on how to calculate the measures of variation for different data sets, and we'll also describe a couple important properties that pretty much distinguish each of these measures of variation from one another. So for a scenario to pretty much walk us through this process, let us assume that you have 7 friends and you ask 4 of them what their weight and their height was, so that you can better understand the relationship between the height and weight of your friends. So let us assume that we want to understand pretty much, the variation between these values in each of these sets. So the first thing that you need to figure out is these sets, samples, or populations. Think about it just for a moment. If you answered samples, then you're correct. The reason being is because you asked 4 out of 7. So if you're only interested in the friends relationship between heights and weights, then if you asked all 7, then that possibly would be a population. Whereas you only have a subset of the population, namely 4 of them. And this is going to be extremely important when we start to calculate the variance and standard deviation of our data sets. Alright, so let us begin by calculating the range of our values. So recall the range of a data set is equal to the maximum minus the minimum values. So the highest value in H is going to be equal to 185, and the least value in H is going to be 162. So the range of these values is going to be 23. The range of the weight values is going to be equal to the highest value, 91, minus the lowest value, 73, and that's going to come out to 18. So from these calculations, we can see that the data for height is more spread out than that of the distribution of weight. Now, a really important thing to note about the range, it is strongly influenced by outliers. So therefore, this possibly is a misleading conclusion based on our values that we actually have, because of a particular outlier value will pretty much tell us that it's really spread out when actually it's not. So that's why we're going to choose the other measures of variation to pretty much describe the variation of a data set. So let us start to calculate the variance. So recall the variance for a sample, remember there is a difference, is equal to the summation of our values minus the sample mean squared divided by m minus 1. And remember that there is a difference between the population variance, which is equal to the summation of our values minus our population mean squared divided by n. But we have a sample in this case, so we're going to take the first equation. So let us start calculating the variance for our heights. So our height values are 162, 178, 185, and 164. So I hope that all of you are able to calculate by now that the average height value is going to be equal to 162 plus 168 plus 185 plus 164, all divided by 4, and that's going to come out to about 172.25 centimeters. Once we have our mean calculated, we can take each of our height values and subtract the mean. So this is going to be 162 minus 172.25. This is going to be 178 minus 172.25, and so on. So you should get negative 10.25, 5.75, 12.75, and negative 8.25 for those values. Then we're going to take those values and we're going to square them. So this is going to be negative 10.25 squared. This is going to be 5.75 squared, and so on. And you're going to get 105.06, 33.06, 162.56, and 68.06. Once you have that value, then we can sum up this last column. So the sum of h minus h bar squared is going to be equal to 105.06 plus 33.06 plus 162.56 plus 68.06. If you add up those values correctly, you should get that this is equal to 368.75 approximately. So that means the variance for our heights, which I'll abbreviate by this. So this is the variance for heights, again, is going to be equal to the summation of h minus h bar squared divided by the number of values we have minus 1. And remember, we need to subtract by 1 because this is a sample. So therefore, this is going to be equal to 368.75 divided by 3. So the variance is going to come out to 122.92. So this is going to be the variance for our heights. So therefore, if we want to calculate the standard deviation for our heights, that's just going to be the square root of the variance for our heights. So that's just going to be the square root of 122.92, which is going to be approximately equal to 11.09 centimeters. And make sure you note that this is in the unit of our data. And this is one of the reasons why we will choose to use standard deviation over the variance of our data. Lastly, we can calculate the coefficient of variation for our heights. So that's going to be equal to the standard deviation of our heights divided by the mean of our heights. So that is going to be equal to 11.09 divided by 172.25. And that's going to be equal to 0.064, or some people prefer to write this in terms of a percent, 6.4%. And this has no dimension or no units on this. And the reason why the coefficient of variation is useful is because it can be used to compare the variation of two sets with different units. So I'm going to go through this entire process again, but now I'm going to do the set W, which was equal to 73, 82, 91, 81 kilograms. If you want to do this on your own and then verify the answers afterwards, please pause the video now and go through those calculations. So I'm going to construct a table, W, which is going to have all my values in it. So make sure you calculate that the average weight is going to be 81.75 kilograms. I'm then going to take all my values and subtract the mean weight, and then I'm going to take those values and I'm going to square them. Once I've squared them, I'm going to add up that column, divide by n-1, and that will give me the variance. So once you complete this table, you should get negative 8.75, 0.25, 9.25, negative 0.75, 76.56, 0.06, 85.56, and 0.56. Adding up those values, we're going to get that that is equal to 162.75. That means the variance for our weights, which is going to be the sum of the squared differences, divided by n minus 1, which is 162.75 divided by 3, that's going to give us a variance of 54.25. Therefore, the standard deviation of our weights is going to be equal to the square root of 54.25, which is going to be approximately equal to 7.37 kilograms. From here, we can calculate the coefficient of variation for our weights, which is going to be the standard deviation of our weights divided by the average weight, which is going to be 7.37 kilograms, divided by 81.75 kilograms, which is going to be equal to 0.090 approximately, or 9.0%. So let us pretty much compare these values and come up with a couple conclusions. So the standard deviation of our heights was equal to 11.09 centimeters, and the standard deviation of our weights was equal to 7.37 kilograms. Notice here that we cannot directly say that our heights are more spread out than our weights, even though that number is a little bit bigger, but you can convert these units into what we call the coefficient of variation. So the coefficient of variation for our weights and the coefficient of variation for our heights came out to 6.4% and 9.0%. Notice here that they pretty much are inverses of one another. So as you see, that the coefficient of variation for our weights is larger than the coefficient of variance for our heights. So from here, we can conclude that the weights are more spread out with respect to the mean compared to that of the heights. So that is one calculation that you can come up with. And keep in mind, you cannot compare these two standard deviations due to the same or different units. If they are the same unit, you can compare, but if they're not, use the coefficient of variation to pretty much normalize them into the same exact space so you can compare them there. So that's pretty much an overview, again, of how to calculate the measures of variation. Remember, the range is very strongly influenced by outliers, so that's why it's not often used, but it can usually be a quick indicator to pretty much demonstrate how spread out the data is. But overall, if you want to have outliers and you don't really want to sort of clean out those outliers from your data set, you can use the standard deviation of variance and coefficient of variation, which are not as influenced by outliers as the range is, and then you can come up with more sound conclusions about your data set's variation.